as you know, the HEC.
I have one on my keychain.
I was thinking of using my speed.
See, I didn't want to start a war. You don't want to start this one. I'm just kidding. I know.
It depends.
Okay, good evening, everyone. I am Sarah. My background is neuroscience and VR research, specifically into how VR can influence our movements and our sense of self. And we're going to talk a little bit today about how we can use virtual reality for learning, for increasing our brain plasticity. And for that, we need a little bit of basic knowledge about brains. So I'm going to ask you first, what does your brain do for you specifically? Yes, anyone?
Nothing.
Okay, well, you just communicated, so that's right. Yes.
Chemicals, hormones.
Okay, chemicals. There's chemical signals in your brain. We're going to talk a little bit about those specific chemicals in learning. Yes. Anything else?
Detect patterns.
We got that's the A level. We got it. So. And I'm going to use a framework that's pretty new to neuroscience, but it's the best thing I've found out there, and I highly recommend reading about this if this interests you. It's called predictive coding, sometimes predictive processing, and it looks at your brain as a prediction machine. Your brain doesn't actually know what's going out there in the world. It only has access to sensory information. And your brain is trying to actually predict the sensory information in order to understand and create a model of what's going out there in the world. Why would your brain do that? Well, there's a lot of very basic evolutionary ideas that come into this, and also this term of entropy, the amount of states a biological being can be in is very limited. We can't be underwater, we can't be standing in front of cars. There's all these very strong limitations on our biology. And your brain has to learn how to predict that, otherwise it will be a very big mess. So, how does your brain actually do that? Well, your brain combines two streams of information. One of them is what we just said, whatever is coming in from your senses. Your eyes, your ears, your smell, your proprioception. But the other stream, what's actually very interesting, is what your brain has already learned. This is sometimes called priors. And your brain combines these two streams of information by using statistics. So it looks at what it already knows, makes this prediction, sees whatever's coming in the senses, and updates its prediction based on that. So I'm going to give you an example. And pictures always speak better than words. As you can see, we have these two upside-down photos of Margaret Thatcher. Now, these are the exact same two pictures of Margaret Thatcher. I just flipped them around. Hopefully, your brain sees a very big difference now, which it didn't see before. Why is that? Well, your brain has a much better model of faces upwards, right? These are things we see every day. There's a lot of history, a lot of previous knowledge when it comes to faces upwards. There's a lot less previous knowledge about upside-down faces, which makes your brain have much more detailed predictions about upright faces, and then you actually get a lot more prediction error, a lot more detailed nuances when your brain is trying to create these predictions versus upside-down faces. So, a little bit more about your brain. We have 86 billion neurons. This is probably the most complex biological machinery, or not even biological. This complexity level is crazy. But not all neurons are equal. There are very different types of neurons, and they are all in this type of hierarchy. Some neurons belong to low-level parts of your brain, and they just process singular modules of information. Your visual system, your auditory system. Other neurons start already being part of a higher level of processing, where these two types of information start coming together. And then it even goes to a further level of abstraction in sort of your prefrontal cortex, where your brain is starting to think ahead, really long-term goals, and all these things that humans are much better at than animals, and that's why we have a bigger prefrontal cortex too. So, like I sort of started saying, this prediction error is very, very important for brains. Only what you don't predict correctly gets passed onwards through these layers, and actually updates these modules. So if there's some type of prediction in your lower level visual area, it will take that information and push it upwards and upwards into higher brain areas. And this is where VR gets interesting and very important and very different than other types of mediums. VR is not just about what you see with your eyes. VR activates higher levels of your brain because it corresponds to multisensory information. The moment you're in a world and you start moving your head, we get what's called proprioceptive sensations. Our inner ear tells us what's going on, our neck muscles, and the moment that fits what you see with your eyes, we're activating these higher levels of your brain. So for that purpose, that reality is really almost as real, or maybe realer sometimes, than what we're seeing in just in a day-to-day and normal life, right? And of course, the more of these sensory informations we can get into VR, the more real it can become, the more we will activate more of our brain. So if we have spatial audio, great. If we have some hands in there, even greater. If we have haptics, right, when things are vibrating when we touch them, great. And there's also a lot of like weird things that are starting to coming out, very interesting, like smell and bodysuits that you can wear with vibrations. So this is really going to grow as the industry keeps growing. Now, again, let's go back to what specifically is really important about VR and what is special about VR. So VR allows us to control these different types of signals in our brain and to decide whether or not these signals fit what the brain already knows, right? I could, for instance, look up, but instead of looking up, I could show you down, right, in VR. I don't have to actually go with what your brain already knows. And the moment I change these type of things, your brain will create much more prediction error and will have to update itself. So this is the very basic mechanism of neural plasticity. Now, of course, we also have to be careful with these type of things because sometimes we can overload the brain, especially with proprioceptive sensations, right? This is why we get a lot of time motion sickness in VR. If your brain is thinking it's moving, because the visual sensations are showing your brain it's moving, but your inner ear isn't moving, you're getting these conflicting sensory inputs, and that can cause nausea. So whenever we're sort of thinking about these experiences, and we saw lots of really amazing and cool examples of what's out there, you can always start thinking about like these experiences, what in them is based on what we know usually, what is this known reality, and what type of novelty has been induced into this experience and into this world. Okay, one more thing that I really want to talk about today is dopamine. Okay, because this is the very, very important for learning, and there's a lot of misconceptions out there, a lot of very old science. You hear a lot about dopamine being this pleasure thing, hormone, and neurochemical, right? So right now, especially in the predictive coding framework, what we're thinking about dopamine is that it's a precision signal. It has absolutely nothing to do with how good of a time you're having or pleasure, but it is telling you something important is going on right now. And that's why it will create behavior patterns, and very important for learning. Now, what can also happen with dopamine is that it can get sort of confused. And there is a type of design that's happening out there, and you see this a lot in computer games and in casinos, and something that as designers and creators, I am very passionate about people actually being aware of and staying away from, because I think it's not very nice to create these boxes that trick our brain in a not healthy way and create addiction patterns. So I will explain this to you, but please make good use of it and don't take this knowledge to create things that can actually create addiction patterns. So what happens with dopamine? When is it actually activated? Dopamine will be activated whenever your brain has a strong signal and there's randomness in it. This is very, very important. If there isn't randomness, whenever your brain knows already, can predict whatever is happening, then it won't be created. Now this is great for learning. Whenever you get real learning, you need dopamine. But if you just induce randomness, that is noise, for instance, in the casino, right? There's total randomness, there's a lot of bling, 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 so strong signal plus randomness, and your brain will just keep creating dopamine even though it's learning nothing new. It's just trying to predict a pattern that is not predictable, right? And some brains might be more susceptible to that than others. There might be a type of genetic and behavioral aspects of this. But this is something that we see in a lot of computer games, Fruit Ninja, to name a few. Personally, if we're designing for learning, stay away from this, okay? People will just stay in these patterns and not actually induce plasticity and not actually learn things if you're just giving them this noise and bling bling bling. Okay, now we're going to go into specific use cases of how you can use VR for learning. So one of these things is actually to do with spatial learning. We have a part of our brain that's called the hippocampus. It is very important for memory, for creating new memories, and storing them into long-term memory. Now, the basis of this memory is actually a spatial memory. If you look at more primitive animals, the most important thing for them to learn is a type of navigation, where they are in space, how they got there, retracting. And this is really the basic of how we remember things with this context of where we are. And there's a lot of interesting experiments that you can do with these things. And with VR, we can really start manipulating this and creating this type of memory palace, if you've heard the term. And one experiment, this is an experiment I'm running, and it's live now. It's a web VR experiment, so you can use it on any type of VR system. Just go to this website. And it will test whether you can remember more French words if you learn them in spatial locations under the Eiffel Tower versus just a 2D condition. And we are still gathering data, but the hypothesis is that the moment we activate also your spatial cues and you see the word tree while you're under a tree and see the word car when you're in a different pathway, you will be able to remember more information. So something that can be very interesting for any type of learning experience. The next thing that I'm sort of very passionate about, and a lot of what I do, I call it this embodied learning. And this is a lot about skill acquisitions and how we can do this in a very interesting way in VR. So we can literally put you, this is an experiment, not my experiment, but a very amazing one, called, the name here? Gary. And you basically can paint with your hands over a real painter's painting. So you can see the painter painting and just put your hand over hers and listen to her process while she paints and get this very interesting input. And you can just think, like, I'm very excited, I'm going to try to make something with piano, playing. So you can have your hands on top of a pianist, for instance, right? So these are really interesting things that you can do when it comes to skill acquisition. And this is one of my experiments that I did in university. Can I actually teach people very hard movements in VR by doing very weird things to their brain? So creating a circle in one hand and a square in another is known to be a very hard thing for brains. And I wanted to see if I can actually create different feedback loops, and we'll see these different experiments that I did to get them to do this. So one of the things is I just put them in this first-person view of a person succeeding to do these movements. And actually my hypothesis was they do better, right? We think, oh, if you see yourself doing something better, you believe it, you will do better. Well, I was wrong. What happened is that actually people did think they were doing better, but they all did worse. And what seems to happen is, again, remember, we're talking about different type of sensory input that your brain is getting and what your brain has to do when there's conflict between these sensory inputs. So your brain was seeing success, and it was also feeling where its hands were. And after looking at the data, I realized that your brain was probably turning down the amount of sensation you were getting in your body in order for it to fit what you're seeing in your eyes. So the visual system turns out, in this case, to win over the sensory information, and this might explain some of what we're seeing in the healthcare effects that Karama was talking about, why VR can be good for pain reduction. Because if you actually see things, it can disconnect you in some ways from your body, and if your body is right now in a painful situation, you might feel less and sort of just believe you're in a better place and have this different type of prediction. But what did actually work a little bit was when I totally messed up the brain. I let people, when they moved their right hand, they saw their left hand moving, and when they moved their left hand, they saw their right hand moving. So very confusing situation, but in this condition, they actually did a little bit better when they were following another avatar. Which goes to show that sometimes, again, when you really mess things up with the brain, it has to induce more plasticity and destabilize the sort of previous knowledge that you have, right? Part of why we're bad at doing these motions is that we usually have this high-level prediction of just one type of goal that we're doing, right? We either do, I don't know, usually we're pouring a drink or driving a car, and we're not very good at multitasking. But when I sort of make your brain even worse in some ways, or make it sort of like a baby's brain again, because it just doesn't know what's going on with these statistical correlations. It has to create new updates and can actually learn better. So, very interesting. And another great example for this is another experiment, not mine, from a little bit longer ago, where they gave people tails that they control with like little body movements, and very fast these people became able to control these tails in ways that made them better at tasks. So your brain is very, very good at utilizing the plasticity of this body image. And it's very interesting to think about how we can use this to create different types of UIs and different types of experiences. Okay, so a little bit about what I've been doing in the last few months. So I sort of challenged myself and a friend of mine to just create 2 virtual reality demos a month, because I feel this technology is at such a beginning stage that we just have to rapidly prototype and see what works, what doesn't work, in order for us to be able to say like, oh, we get this. So that's what we've been doing, and you can see all of our stuff on, we have every type of social media. No, we don't have an Instagram, sorry. Everything else. And we have a Patreon where you can also download the source files if you want to actually further develop any of these types of prototypes. And we do a lot of different things, but some of them are also to do with learning. And specifically, I wanted to bring types of interactive learning, how we can use VR for interactivity, and also use very natural user interfaces. Because when I look at what's out there, and I try a lot of different new VR experiences, mostly they're still stuck in this menu system. You get beautiful visuals. I've been in a lot of these like biological teaching experiences, neuroscience experiences that are trying to teach you about brains, and it's beautiful. Like what they can do on graphics is amazing. But the interactivity is usually very, I'm gonna say primitive. It's very like based on, okay, you point at a menu, you can maybe like change some variables, in a very unnaturalistic way. And what we're trying to do is create this much more interactive learning situations with, again, with your body. So we created, for instance, in social VR, I think we mentioned VR chat. It's a social VR world with anybody can just put up their stuff in there, and people from all over the world can go in, even just with a desktop, which is sort of nice. So we created a world that's dedicated to the neuroscience of VR, so people in VR can learn about what VR is doing to their brain right now. Because we're very strong on like educating users. Know this is powerful. Know this can influence your brain. Don't be duped into these experiences that might create possible bad effects. And we have their like neurons that you can actually trigger by touching them. So you can touch the dendrites, and that will activate the axons of the neurons. And you can do this together with a group of people activating, different parts of and different neurons and seeing all these like nice firework patterns. And there's a bunch of other different things you can do there interactively to sort of learn about how VR influences your brain. Another thing we created was, I call this Fractal World. Fractals are very complicated, mathematical structures, and I wanted to give people an intuitive feeling of how they work. So you can go into Fractal World and based on the movements of your hands, you can change parameters there just by like moving your body, and get this intuitive feeling of the different parameters that influence fractals. The same, a little bit similar, but not exactly, we did with a gravity simulator. So you can actually play with gravity, and this is a voice UI, so you can just say, higher gravity, lower gravity, and throw these earths, and see what happens. How the throwing, how the speed will change. You can say change direction, and the gravity will change. So again, very interactive ways to teach your brain about science and math. So that's one. And I guess what all these years of experience have sort of brought me to, and what I'm trying to build up now, is a very early startup called Radix Motion. We're trying to increase wellness and productivity in the workforce by creating these healthy movement breaks in VR that will teach you about your own body, give you better feedback into your body, into your posture, and also create this social incentive to play these games. So you can create these games for your friends, movement challenges, and send it to them. See like a 20-second. So the idea is, even me as a mover, I code a lot, and when I do that, I get back pain. And we can do, by utilizing the sensors, I can actually give people personalized movement training. I can know about their posture, I can know about their range of motion, and create specific exercises for them. And the idea is, again, to create some type of game. You can create, we have a few different modules. This is like Twist Me, where you put things in space for your friends, and you send it to them, and they can actually start twisting around, searching for the things that you've sent them. Another game is called Follow Me, where you create a little dance, and you can then send that to your friend, and your friend will have to follow you. Yeah, and this only moves, right? So she actually has to touch these hands exactly for this to work. So we're at a very early stage of that. So if you know, I'm currently looking for HR people to talk to. I'm going to utilize this stage. If you know any HR people in charge of wellness program, we're interviewing them. And of course, angel investors, very important.
Yes.
And finally, yeah, that's it.
I'm talking with the camera.
Thank you, Sarah. Okay, so now we're going to make time for Q&A. So if I can ask Clarama and Sarah to maybe stand back up here.